we have a harmonic progression, and the first two terms of that particular progression are provided to us. The first term is 2 over 5 and the second term is 12 over 23. We need to find the largest positive term of the harmonic progression. So let us begin. So what we'll do, instead of starting with a harmonic progression, we'll start with a arithmetic progression with, let's say, let the first term be denoted by the letter A in lowercase, and then the common difference, since it's an arithmetic progression, common difference be denoted by the letter D in lowercase as well, of an arithmetic progression. Fine. Now we are provided with the first term of the harmonic progression. So it's given the first term of the harmonic progression that's equals to 2 over 5. But we know that if we have the first term of the harmonic progression, then the first term of the arithmetic progression, that will be simply equals to the reciprocal of the first term of the harmonic progression. So that means the first term of the arithmetic progression will be 5 over 2, or simply A value is 5 over 2. Then we are also provided with the second term of the harmonic progression. Here the second term of the harmonic progression is 12 over 23, which means that the second term of the arithmetic progression, so that's going to be simply the reciprocal. We have 23 over 12, and we know that the second term can be also denoted as A plus D equals to 23 over 12. Now what we can do, we can replace the value of A with 5 over 2. So we're 5 over 2 plus D equals to 23 over 12. So solving for the value of D, so we have D equals to 23 over 12 minus 5 over 2, which can be also expressed as 30 over 12. Okay, fine. Now this D value comes out to be negative 7 over 12. So now we have the first term, now we have the common difference. So let's try to find out the largest positive term of the harmonic progression. To do that, we'll start by first finding out the nth term of the arithmetic progression. So the nth term is given by A plus n minus 1 times the common difference D. So we'll substitute A with 5 over 2 plus n minus 1 times negative 7 over 12. So that will be equals to, so let's rewrite 5 over 2 as 30 over 12 plus minus n minus 1 times 7 over 12. So if we take 1 over 12 as the common factor, so we have 30 minus n, 7n plus 7. So that means we will now have an given by 1 over 12 multiplied to 37 minus 7n. So this is the nth term of the arithmetic progression. So that means the nth term of the harmonic progression, that will be the reciprocal of the nth term of the arithmetic progression. That means we have 2 over 37 minus 7n. Now what we'll do, we will suppose that since we have to find out the largest term, so let us suppose that the largest term of the harmonic progression be 12 over 37 minus 7n. If this were to be the largest term, then the denominator 37 minus 7n has to be the smallest one. That means it's going to be the we'll have to find the least positive value of n, which is going to make 37 minus 7n as small as possible. Okay, so let's start with this. So if we choose n to be equals to 1, then we have 37 minus 7, so that corresponds to 30. If we choose n equals to 2, so we have 37 minus 7 times 2 is 14, so we're going to get 23. If we choose n equals to 3, then we're 37 minus 21, so that will be equals to 16. And if we choose n equals to 4, then we have 37 minus 7 times 4 is 28, so we have 28, so this will be equals to 9. And if we choose n equals to 5, so 37 minus 35, so this will be equals to 2. So as we can see, as we increase the value of n, we see that the value of the denominator 37 minus 7, that's decreasing. But if we choose n equals to 6, then we're going to get a negative value. We need the positive, we need the value of n such that this value is the least as well as positive in nature. So that means the fifth term will be the largest term of the harmonic progression, and its value is, all we have to do is replace the value of 37 minus 7n, so that's going to be 2, so we have 12 over 2, so, and its value will be 12 over 2 will be 6. So that's the final value.